Safe light repair, safe light replace. No. Safe Farm? Yeah, like a good neighbor, Safe Farm is there. Okay, you ready? On your mark, get set, go. Here we go. Option number 1. If you would like to simplify trigonometric expressions, we spent Friday talking about rewriting them in terms of sine and cosine. That is option number 1. If you would like to substitute, that's something else that we talked about as well. And the third thing we talked about was factoring, and that's where we left off right now. So I want you to look at letter Q. Is there something that you could factor in that situation? What can you take out of both terms? So let's look at the two terms. What's something that looks the same in each term? Sine squared of theta. If you factor out a sine squared of theta, what remains? Secant squared of theta minus 1. Awesome. Now it becomes a problem like we did on Friday, where we use a method of substitution. What is secant squared minus 1? Tangent squared. Secant squared minus 1 is tangent squared. If you note this sheet of formulas that you were given, the secant squared minus 1, you can see right here, is equal to tangent squared. Olivia, just show patience, and the first video will be important to watch. Okay. All right, so sine squared times tangent squared. Now what? Sure, sine squared of theta over 1 times sine squared of theta over cosine squared of theta. Now, does anything cancel in that scenario? Nothing cancels at all. And so therefore, that doesn't really help you. So don't try to do that, just leave it like this. Okay, so you might try to simplify something and realize, uh-oh, nothing cancels. I can't do any more with that. If that's the case, then just you be you. Yeah. Letter R. Yes. What would you like to factor for letter R? Yes. Cosine squared of theta. That's a thought. Let's just do this first. Let's factor out the cosine squared, and what are you left with? 1 plus tangent squared. Oh boy. So suppose you had, say, x squared plus x squared y squared. If you factored that, you would have x squared times 1 plus y squared, correct? So, well, these are factoring just like each other. So in terms of like what happened to the other one, I'm taking a cosine squared from each term. Yes, no? Okay. What is 1 plus tangent squared? So cosine squared times secant squared, what's the relationship between cosine and secant? They are reciprocals, right? And what happens when you multiply reciprocals? You get 1. Sometimes people on the test, when they don't know what they're doing, they just write 1 and they put a box around it. And you can do that, but you may not receive points for it. You must justify your work, okay? So that'll give you half a point. Yep. Yep. I'm one of those teachers that makes you show that you know what you're doing. It's like My choice. Okay, here we go. That'll be fine. Tangent squared of theta over secant minus 1. What makes this different and slightly more difficult is that there's no squared. And here's what you guys have to keep in mind. You know now that secant squared of theta minus 1 is equal to tangent squared. That's something that we have learned. But this is not true. Secant of theta minus 1 is not equal to tangent of theta. You can't just take the squareds off and magically have them be the same. It does not work like that at all. Not at all. It would kind of be like saying that suppose 3 squared plus 4 squared is 5 squared, which is true, right? 9 plus 16 is 25, agreed? And you're like, I'm just going to get rid of the squared. So 3 plus 4 is 5.
Yes.
Okay. Totally illegal. Doesn't work. So can't do that. But what I want to do here is I'm going to actually substitute something in for tangent squared. I just wrote on the board that tangent squared is the same as secant squared of theta minus 1. Is everybody okay with the substitution on the top? Now, I recognize that the top actually factors. It's the difference of two squares. If you had x squared minus 9, it would factor to what? X squared minus 9 factors to x plus 3, x minus 3. So secant squared minus 1 is going to factor to So I factored the top, and notice that it matches with one of the factors in the bottom. So now you're left with being smarter every minute. Good job. All right. So this next one, cosine of theta plus 1 over, anybody know what I'm going to plug in for sine squared? Kind of builds off of the last problem. 1 minus cosine squared. Good. Sine squared is the same as 1 minus cosine squared. Does 1 minus cosine squared factor? Yeah, so cosine theta plus 1 on the top, and in the bottom, what are you going to have? How does it factor? Close. Good. Good. And what happens? Sweet. I like it. So far we've talked about changing things to sine and cosine. We've talked about substituting. We've talked about factoring. Sometimes you just need to multiply things out and see what happens. Like in this situation, I'm going to distribute the secant through the problem. What is secant times secant? Secant squared of theta. And what's the relationship between secant and cosine? They are, and if you multiply reciprocals, you get 1. Secant squared minus 1 is tangent squared of theta. Let's try multiplying the next one through. Sine times sine. Sine squared. I like that. And then sine times cosecant. 1. So you're just left with cosine squared. Shoot, I wish I knew what sine squared plus cosine squared was. It's 1, right? Yeah.
Okay, I'm confused.
Okay. So sine times cosecant is 1.
Whoa.
So that means you're just left with 1 cosine squared.
So you have to keep that one in the equation, like write it out. So,
I mean, there's a 1 in front of this one, right? No, if I could show you a somewhat similar. Suppose you had 4 times 4 plus 1/4 x. Okay, so 4 times 4 is 16, right? And then 4 and 1/4, that just makes 1, right? So 1x. Similar scenario right there. Okay. All right, flip it over. Here we go. All right, I'm gonna multiply these out. Multiply them. Tell me what I get. 1 plus cosine of theta minus cosine of theta minus cosine squared. Notice that they're conjugates. When you multiply conjugates, what happens? The middles cancel. And that's a common theme that will come up in this class from here to the end of the year. Middles cancel, so you're left with? Shoot, I wish I knew what 1 minus cosine squared was. Uh-oh, are the next ones conjugates? Yes, they are. So we multiply them, you know the middles are going to go away. So you get tangent squared of theta, then what? Minus secant squared. What is tangent squared minus secant squared? I'm hearing x, and I'm hearing 1, I'm hearing tangent. Okay, so when people write tangent squared minus secant squared, a lot of people put 1, and that is not correct. So if we could please just look at this formula, and let's generate a tangent squared minus secant squared. I didn't put all of the formulas on here. I just put the most important ones. So if I want to generate tangent squared minus secant squared, notice I'm going to subtract the 1 over, right? And then I'll subtract the secant squared over. And I'll get tangent squared of x minus secant squared of x is equal to? Negative 1. So it is negative 1, not positive 1. You will not be prepared for the things to come. All right, if I multiply this out, what am I going to get? 4 secant squared of theta. They're just going to cancel. I get a minus 4. All right, excellent. Factor out of 4. So you get 4 secant. So negative 2 times positive 2. All right, Ella, what is secant squared minus 1? No. Oh. It's tangent squared. Come on. All right.
Ella, if there's a square that needs to be squared. How did you not see squared? We multiplied 1 by itself.
So sometimes we get to other kinds of problems that don't have as intuitive of solutions. So in this situation here, cosine times tangent plus cotangent times cosine, some people say factor out the cosine. But when you do, you're not left with anything that really helps you. And so for the approach to this problem, I'm going to go back to changing things to sine and cosine. So cosine over 1 times what? Sine over cosine. Plus what? Cosine over sine times cosine of theta over 1. Let's talk about our approach and why it's a good approach. First of all, wouldn't you agree it's a good thing if you get a squared and a 1? Squareds and 1s are good, aren't they? Because this page right here has a whole lot of squareds and 1s on it, doesn't it? But we don't have a squared or a 1. We don't have much of anything. I do see this. I do see that the cosines will cancel. Do you see that a squared will be created at all? Where? Yeah, cosine times cosine is cosine squared. So notice I have sine of theta over 1 plus cosine squared of theta over sine of theta. Awesome. I have a cosine squared. What's great to pair with a cosine squared?
Wait, don't the signs cancel out? No,
It's okay. What's great to pair with a cosine squared? A 1 or a sine squared. Look at what I can do. I have fractions. How do you add two fractions? What is the common denominator? So if I multiply the top and bottom by sine, what will I create? I will create a sine squared. So notice what I get. At the top, I have sine squared of theta plus cosine squared of theta. What do I have in the denominator? Sine of theta. At this point, I can't really help you. You just have to see it. What is the top? Very good. Sine squared plus cosine squared is 1. Over sine? Cosecant.
Are we supposed to have like that all night? Like take you I feel like checking.
Sine square plus cosine square is 1.
Yep. Did everybody get to this point? I'm going to multiply the top and bottom by cosine in order that they would have the same denominator. And I get sine squared of theta plus cosine squared of theta over, what's my new denominator? Cosine of theta. What is sine squared plus cosine squared? 1. My denominator is cosine. Can somebody tell me what is 1 over cosine? It is secant. All right, so we have 3 more problems. I have 1 minus cosine times sine times tangent, okay? And so in this situation, I'm going to write as 1 minus. I don't see anything that cancels. I don't see anything that factors. So maybe if I just write it out in terms of sine and cosine, maybe I will see something good happen. Anybody see something good? Yeah, the cosines cancel, leave me with 1 minus sine squared. Wish I knew what 1 minus sine squared was. It is cosine squared. Very good. All right. So the last thing we want to talk about is our last kind of options. We actually already looked at an example where we've kind of added fractions together, and we find that when we do that, sometimes things cancel, right? So that's been a nice part. But then also we want to be able to deal with, say, complex fractions. And so let's look at these 2 examples. Both involve fractions. Both are a little bit more challenging. And congratulations, you've kind of made it to, if you could do these problems on your own, you'd be ready to get an A on this test. But the fact is that most people, when you walk away from this, you don't remember, and That's kind of how it goes. And so let's try. And you just have to understand, the problem doesn't care really whether or not you're a nice person, does it?
Well, the problem
I'm just saying our grades are pretty good right now, right? This is the unit that will separate us a little bit, okay? And that's just the nature of it. Wish I could make it different, but it's not. All right. I don't see anything that's going to cancel. So what I would like to do is I would like to take the challenge of combining these two things as fractions. If you could combine them as fractions, what do we have to have? Common denominators. So I'm going to multiply the top and bottom of this by what? Sine of X plus 1. So X and theta are variables. You can use U, you could use B, you could use theta, you could use, yes. Yes, theta represents the angle measure. X represents the angle measure as well. Okay, over sine of X plus 1. A variable is a variable. Doesn't matter what you put in there. Thank you. All right, so this side we'll multiply by cosecant of X plus 1 over cosecant of X plus 1. What am I going to get in the top? Everybody okay with that? And then in the bottom, I have cosecant of X plus 1 times sine of X plus 1. And there we go. So what Luke would like to do is Luke would like to just cross these both off and get 1. We all good with that? So let's talk about why we can't do that. Suppose you had 7 plus 8 over 7 times 8. Okay? Can you just cross those off and say it's 1, even though you know it's 15 over 56? You get my point? It's very illegal. Okay? So, I don't see something that's going to cancel here. My best bet is to try to multiply out the bottom and see what happens. So I have cosecant of X plus 1 on the top, plus sine of X plus 1. And I'll multiply out the bottom and just see what I get. Okay? What's cosecant times sine? They are reciprocal, so we get 1. And then cosecant times 1 is cosecant. And then 1 times sine is, and then 1 times 1 is 1. Is the top the same as the bottom? They are now exactly the same, aren't they? So it is 1. Yeah, if you like to be a logical person that has answers that are established in reason. And as a person who appreciates mock trial, I would say that you would agree that argument matters. What's that? You can try that approach. How about I just start grading you the way the college professors do? Okay.
I would agree with no simple mistake.
All right, so this next one, the last one for the day, sine of X over 1 plus cosine of X. And so hold on, before we even start that, I just want to be clear. This problem is testing a few things. Before we even get to that spot, here is what I do see on the test. I see this. sine of x over 1 plus cosine. Do either one have a squared? But yet people still choose to just substitute stuff because they don't know what they're doing. And so instead of 1 plus cosine, they will do this. They'll just substitute sine. Okay? And then this makes 1. And then they remember that a 1 and a cotangent sometimes has something to do with cosecant, so they just say, we're done. Okay? You get my point? So that we cannot do. So let's just try to add these together. What do we get? Common denominator. So I'm going to multiply top and bottom by. So why am I liking our approach right now? What's good about this? I get a sine squared right now. That's an attractive thing. Okay? And then on this side, I multiply by 1 plus cosine of x. All right, let's look at the top. What is sine times sine? Sine squared of x. Plus, what's cosine times 1? Cosine of x. And then plus cosine squared of x. So that's what I have in the top. I like to multiply out the top. I like to leave the bottom in factored form. And the bottom is sine of x times 1 plus cosine of x. I like to leave the bottom factored until I see that nothing really cancels and I have to actually multiply it through. So, again, at this point, I can't do anything for you. You have to recognize this. What do you see? I tried to give you a hint early on. I was excited that I created a sine squared.
Sine squared plus cosine squared is 1.
Yeah, sine squared plus cosine squared is just 1. 1 plus cosine is in the top. One over sine, which is cosecant. It was. I've never actually done it like that before using voodoo math, but crazy. All right. So, part of what I found really works for people is doing a lot of examples. We've seen a lot of examples. I would guess that, there's probably 4 problems on the first assignment that 90% of you would need help with. So when you come across a problem that you don't know how to do, don't just spend 30, 40, 50 minutes trying to figure it out. Move on to a problem that you do know how to do. Tomorrow, we will not have a lesson. You will start working on the second assignment on simplifying trigonometric expressions. The common response from people is, Mr. Gens, I get what we're doing when you're helping us in class. But when I try it on my own, I don't know what we're doing. And that's something I have to help you through because without a doubt, yeah, I wish I could just tell you the way to do it every time. But this is kind of it's the measure of how good a math student you are at this time. Okay, so some of you will measure higher than others. And I hope you can all do extremely well.